Hi everybody, welcome to discussion number 3 for SocSci10. And I want to talk about some statistical measures today you're going to need to know for your homework. And you probably remember some of this material from the very first exam, which I graded. I hope you guys did well. If you have any questions, you can write me. I can send you a copy of the rubric so you can see how they were graded. I wasn't given a lot of leeway about extra points. But listen, I heard that the score from Paul, the professor, says that the scores are about right. It looks like the average is going to be a B once the scoring is taken into account. But out of the total points, it may not look so great on initial glance. But the average, well, he says it's a B. So even though the numerical scores are not so great. So I wouldn't worry too much about it, but if you're really concerned about the scores, I can send you the rubric, but I'm not going to publish it in general. So you're going to have to write me, and then we'll talk about it. Maybe I'll send it to you so you can see how I was told to grade the exam. Okay, so that out of the way, why don't we talk a little bit about these statistical measures that you're going to need to know something about for the homework. Okay. So first we're going to talk about is the mean. Now the mean is probably the most common statistical measure. Everyone knows this one. You guys should know it and learn to love it. It's the best. It's typically spelled with a little u, but that's not actually a u. It's a Greek letter. It's a mu, M-U. That's right. And you can see here this little formula. Mu equals the sum of x, where x are all the numbers. You're going to sum up all the numbers, and you're going to divide that by n, which is the number of numbers that you've added up. This is how you compute an average of values, right? And this is the mean. And you'll often just see, if you see the letter mu, which it looks like that U with the tail in the front. If you see that letter mu, they're talking about the mean. You just know what it is. It's used everywhere like that. Okay, so let's talk about the next one. The next one is the median. This is the middlemost value in a list. If you have a list of values and you sort them, so you have like the smallest values to the largest, or the largest to the smallest, doesn't matter. But you have a sorted list of values. The one that's exactly in the middle, that's the median. Okay, it's not as good a statistical measure as the mean is, because when you're looking at a sample, the median there's a little more likely to be error in the median from a sample, between the median of a population and the median of a sample from that population than there is between the mean. Right? It's not quite as good, but it's useful for some things. It's not as affected by outliers as the mean is. But maybe you want to be affected by outliers, right? So the mean is a better estimate of the overall population, but the median can be useful if you know there's going to be outliers and you don't want them to affect the value. Another type of statistical measure is the mode. This is the value that occurs most often. So while you look at your list of values and you figure out how many values of each number that you have, and the one that occurs most often, that's the mode. All right? Now, what about the trimean? This means somebody is 3 times as mean? No, not quite. But the trimean is a clever statistical trick you can use where you're looking at the quartiles. Now, if you remember the 25th quartile, the 50th quartile, and the 75th quartile, these statistical measures tell you where 25% of the data is underneath the 25th quartile, 50% of the data is underneath the 50 quartile, and 75% of the data is underneath the 75th quartile, right? And you can do a weighted average of these quartiles. And the key trick here is you got to count the middle one twice, right? So you count the 50th quartile, whatever value that is, you count that as double. And you can see here the formula that we have for the trimean. You take the 25th quartile, that marker, where 25% is below it and 75% is above it. Then the 50% marker, right? You double that though, okay? And then the 75% marker, and you add them up. You divide by 4 because you're taking the middle quartile, the 50th quartile twice. That's how you compute the trimean. It's useful. Now the geometric mean is a little different. This is an interesting one where you take the product of the n numbers, and then you take that product to the nth root. So the formula here looks like it's a little bit distorted, but what this formula here is, you'll see this symbol kind of looks like pi if you're taking math, but actually that when it's a capital like that, it means the product. And the product, and you see it has an x, a product of x, where x takes on all the values in your sample or in your population. So you take all those values, you multiply them all together. So you can get a really big number. But then you take the nth root, right? And that's square root, that would be the second root. You could take the third root, that would be the cubic root, right? But what you're really going to do is you're going to take the nth root. And the way you typically write that is when you're doing the exponent, you're going to do the 1 over n. That will be the nth root. And if you remember from your algebra, that basically means you can move that entire parenthesis shown in here underneath of a fraction. You put it in a denominator of a fraction, and it will invert the power, right? So if you have the square root of a number, that's equivalent to 1 over that number squared, right? So you take the square root and you turn it into squared by moving it into the denominator of a fraction with a 1 as a numerator, okay? And you're showing that instead of using the typical square root symbol, which has the v followed by the divide line, right? You can just show that a little easier algebraically for manipulating by using 1 over n to show the nth root. Similarly, if you want to show a square root, you would do 1 over 2, and you could do 1 over 3 for a cubic root. But that's the geometric mean. You multiply all the numbers together, and you take it to the nth root. Now, the range. The range is actually the region of the number line that are occupied by values. So what you do here is you look at your values, you find the smallest one, the largest one, right? That's the range. Everything occurs in between those two endpoints. That's the range. Now the interquartile range, right? You're looking at the middle 50% of the data set, or your sample, or the population. But what you do is you figure out what the 25th quartile line is, the 75th quartile line is. So you're ignoring the bottom 25% of the data, and you're ignoring the top 25% of data. You're just taking that meaty chunk, that 50% right in the middle, the meat, right? And you're just going to look at what's the area between the 25th quartile marker and the 75th quartile marker, right? That will be the 50% of the data. It'll be in that area. That is the interquartile range. Okay, so if you have a lot of outliers or a lot of stuff that's at the edges of your distribution, by looking at the interquartile range, you can really focus on trying to capture something interesting if these outliers and extraneous values at the extremes of the range are kind of throwing off your measure from what you're really trying to analyze. So that can be useful in some cases. Now, another thing you need to know is the variance. Now, the variance is very important, okay, but this shows you how different the scores are on average from the mean. And you do this calculation in the following way. You will see that you get this sigma, which looks like an O with a line coming out the side of the top, squared, and that equals the sum of each value subtracting the mean from it. Square that difference and divide the whole thing by the number of values that you have. Okay. Now the variance, that's sigma, which is the circle with the line across the top. It's a Greek value. It's a Greek letter once again, and you can see that the mu is in the. I'm just talking about coffee ever. You can see that the mu is actually in the numerator of the fraction there, right? So remember how you compute the mean. And you see that mu there. You know that means the mean of the sample that you're looking at. And so what we're doing here is we're looking at the difference between the mean and each number. And we're squaring that difference, so we're turning all the negative differences, right? Because it could be negative or positive difference. We're turning them all positive, and then we're going to sum them up. We're going to add them up, and we're going to divide that by the number of values in our sample. Now that's going to give us sigma squared, right? Now sigma squared, that's the variance. Why? Because our very last statistical measure we're talking about is the standard deviation. That's the square root of the variance. So really, sigma, just plain sigma, that is the standard deviation. And when you square the standard deviation, you get the variance. Okay, so that's how the variance and standard deviation are related. Standard deviation becomes very important when you're looking at normal distributions and other factors, and you're going to learn a lot more about that. Now, each of these statistical measures, you got to know these statistical measures. You're going to use certain statistical measures sometimes and other ones not so often. It really depends on what the character of the distribution you're looking at. Which ones will be useful, right? Sometimes the mean is almost always useful, but sometimes it's not if you have a lot of outliers that are pulling that mean to one side or the other. Maybe you want to talk about the median then. Give you an idea where the central mass is located. Well, maybe you could use the trimean, right? So let's say we don't have like all of the different values, but we know that we have these quartile ranges. Well, we can compute a mean from the trimean then and get some kind of value about the central tendency of the data. So, and then you can also look at the interquartile range. If you just have the quartile markers, for example. So each one of these is used in different cases, and depending on the distribution, how the data looks, you might want to pick one or more of these to describe the statistic, as a descriptive statistic. So. Now don't forget, you got your homework due tonight, and take a look at your test scores. The average I think was something like 85 out of 150, but that's a B, so don't panic over much. And send me an email if you want to talk about the score, and and good luck, and I will talk to you guys next week.